Good morning.
Good morning, Greg. And I'm actually, since we have a lot to accomplish, I'm going to start. First thing I'm going to do is go as quickly as I can through the basic stuff you need to know in order to do homework 6. There are 2 students, one has got 100%, the other's got 98%. And so 2 students have basically successfully completed homework 6. You know who you are. God bless you. That's really amazing. You are invited to stay. On the other hand, if you don't want to, you don't have to, but I really think even if you've got a really good grade, sticking around, you might learn something that is new. So I'm going to start with the quick and dirty explanation of what this concept is all about. And after we do that, I'm going to do some homework problems from homework 6. And after that, anybody who wants to talk about assignment 2, I'll stick around and we can talk about assignment 2. So that's a plan. Is that okay? Hopefully, yes. Okay, so I'm going to do a new screen share. Okay, and let's see what we've got for a new share. We've got this. Okay, so we're going to be talking basically about confidence intervals, but only today about confidence intervals for proportions. There are 2 symbols and you don't want to confuse them. Little p without a hat on it is the real deal. It's the real population proportion. We will never know that. We're trying to estimate it. There is only one p. P hat are the sample proportions. There are lots of sample proportions. Every time you do a new experiment, you get a new p hat. So there's lots of those guys. Suppose you're trying to estimate this real p, proportion of college students that are female. What do? You go out there and you start collecting data. First of all, every sample you take has 25 university students in it. And then you count and find the proportion of females. My God, on the low end, there's only 40% females. And on the high end, there's 90% females. So there's a lot of variability when you only have 25 students per sample. What you see along this x-axis are p hats, sample proportions. You up the sample size to 100 and things change. There's less variability. You can check the mins and the max. And StatCrunch is very good at computing means and standard deviations. You'll notice a lot of variability when you've only got 25, considerably less variability when you've got 100. They both look bell-shaped. What does that mean? That means that if you have a really large sample, the mean of the p hats, sample proportions, is going to be the real deal. And if the sample size is large, the p hats will be normally distributed. Okay, another observation is variability. I'll just put this in English. It says, the bigger the n, the less variability in the sample proportions. Big idea. Sample proportions are normally distributed. The mean of the sample distributions is the real deal. And my God, they even have a formula for the standard deviation. A little complicated. Square root of p, 1 minus p over n. How big does the sample size have to be? There's some criterion here. I'll let you read that because I'll post the PowerPoint. And there's a little bit of a problem. The formula for the standard deviation says P times 1 minus P, but we don't know P. That's what we're trying to estimate. So we have to fudge it. We create a new statistic called the standard error. The standard error is the fudge factor. You can't use P because you don't know it. So you substitute in P hat and you call this new statistic the standard error. Now, here we go. You might not like to do this, but I want you to think back to the empirical rule. What does the empirical rule say? It says that if you go out two standard deviations, you capture 95% of the p-hats. Okay, so here is the computational counterpart of that. Here is the p-hat, the 1 minus p-hat, the 2 for the 95%, the 100 because we put 100 students in each sample. So we do a little arithmetic. This term here is 0.098. This 0.098 has a name. It's called the margin of error. You might have heard of that. We're trying to estimate the proportion of females. How close can we get? Give or take 9.8%. This is the margin of error. So if we take that margin of error and subtract it on one end and add it on the other end, do a little add and subtract, what we get are some boundary values, 50% and 70%. Okay, let's put that together. You put it all together, and when you do the give or take the margin of error, you come up with your first 95% confidence interval. In English, it says the true proportion of female students in that university is between 50% and 70%. And I can say that with 95% confident. So I'm 95% confident that the true proportion lies between these two values. That's great, because one single sample proportion, if you just run one experiment and get one p-hat, that tells you nothing. You've got to do it many, many, many times to get a handle on what the true proportion is. And I change that into percents. Okay, so truth be told, the empirical rule kind of made things easy computationally for us, but the 2 is really not a 2. It's a 1.96, and the 3 to capture 99% isn't really a 3, it's 2.575. So how do you, if you were to physically do this by hand, what would you be doing? You'd be putting in your sample proportion, a z-score, depending upon the confidence level, and your p-hats. Those are the computational formulas. Reminder, your homework is going to talk about the margin of error. What's the margin of error? It's the quantity that you add and subtract. It's give or take so much. What about the Z-score? That depends on the confidence level. If you want to capture the middle 90%, if you want a 90% confidence interval, it's 1.645. 95, a little bit bigger, 1.96. 99, a little bit bigger, 2.575. So the Z value gets bigger and bigger and bigger depending upon how confident you want to be. So how can you manipulate? This comes into the homework. How can you manipulate the margin of error? You want the margin of error to be smaller. If you want the margin of error to be smaller, put in a smaller Z value. Trade-off, you'll be less confident. Or you can increase the sample size. A big number in the denominator makes all of this smaller. So there's two ways to manipulate the margin of error. Reduce your confidence, increase your sample size. I've just answered that question. How do we interpret a confidence interval? So we took a sample of 100 from a population of students, and we want to estimate the proportion that are female. We come up with this 95% confidence interval. So you're going to have multiple choice questions on the homework. How do you interpret it? You're going to look for the word confident. You should say, I am 95% confident that between 51% and 69% of the college students are female. Alternatively, you could say about 95% of the random samples of size 100 will produce confidence intervals that contain the true proportion. That's all I have to say. It's being recorded and I will send you the PowerPoint. So I guess the questions will come up when we transition to the homework. Okay? So let's see what the homework has in store for us. Where's the homework? Here it is. Okay, so I'm going to have to move you guys over. Okay. There's the homework. There are 14 questions. So I've made an executive decision that we're going to not start with problems 1 and 2 because it involves taking a square root, and I do not want to spend all of this time bogged down in calculator mechanics. So we are going to start with problem 3. So we're going to start. And we're going to start with problem 3. So problem 3 says a polling company conducts an annual poll of adults about political opinions.
Can you switch your screen over? It's still on the homework page.
Oh,
Question
thank you
page.
for telling me that. Okay, I gotcha. All right. So we have new share and no, it didn't switch, did it? New share. New share. Here it is. Here it is. Thank you for speaking up. Okay. Polling company conducts a poll about political opinions. They asked a random sample of 491 adults whether they think things are going in the wrong direction. 51% of the sample, okay, said they think things are going in the wrong direction. We're going to click yes, because if we didn't click yes, there'd be nothing to do. So yes. Okay. The margin of error for a 90% confidence interval is 0.037. Now, if we reduced the confidence level from 90% to 85%, what would happen? So in my mind, I'm thinking about that z-score. I'm thinking, what happens to a z-value? What happens to a z-value when you reduce the confidence? We saw that. Every time you reduce the confidence, the z-value gets smaller. They haven't changed the sample size. There's no mention of changing the sample size. So we only want to look at A and D. Let's see. A says, to be less confident, the interval needs to contain the true proportion less often, so the margin of error would be smaller. To be less confident, the margin of error needs to contain the true proportion. What does it say? More often. Okay. So the margin of error would be smaller. So think about it. Your z-value is getting smaller. As your z-value gets smaller, things get closer and closer together. So you get a smaller margin of error. So the answer would be D. Let's check it. What? Okay, before we look at the next question, let's look at that. To be less confident, the interval needs to contain the proportion less often. Obviously, okay, I'm sorry. So the margin of error would be smaller. Margin of error is smaller because the z-value is smaller. So, my bad. If the z-value is smaller, the interval gets wider. If it gets smaller, so the real proportion could be out there and you missed it. What about problem number 4? A medical researcher estimates the percent of children exposed to lead paint, and the margin of error is estimated to be 6%. What does this mean? Doesn't mean the 6% estimate is invalid. It means the true proportion is within 6% of his estimate with some level of confidence. They didn't mention a level of confidence, so that sounds good. It's not about the sample proportion. Okay, this is it. The true proportion is within 6% of his estimate with some degree of confidence. Check answer. Okay. A student is considering publishing a new magazine aimed directly at owners of Japanese automobiles. He wants to estimate the fraction of cars in the United States that are made in Japan. Computer output gives you this 99% confidence interval. So I'm going to take a moment and have you look at these 4 options and read through them. We are 99% confident that between 29 and 47 of the cars in the United States are made in Japan. It is probably true that 38.5% of the cars are made in Japan. We don't know exactly, but we know that, oh my God, they're doing some arithmetic here. We don't know exactly, but then they do some arithmetic and they say, we don't know exactly, but we know that it's between 29 and 47. And there's a blanket statement that 38.5% are made in Japan. Anybody want to offer a suggestion about what the correct answer is to that? There's a key word you are looking for.
Probably A, right? Because it says the 99% confident.
A confident. Always look for the word confident. All of the rest are BS. Look for the word confident. Check answer. A study of 937 decision to grant parole or not made by a parole board produce the following computer output. Assuming the cases are a random sample of cases that come before the board, what can we conclude? Okay, it's a 98% confidence interval. It runs from 55% to about 62%. We're 98% confident that the true parole grantees is between 55 and 61. We are 98% confident that the sample is between 55 and 61. There's a 98% probability of blah, blah, blah. The probability is blah, blah, blah. So what's the subtle distinction between A and B? What's the subtle distinction? A is a broad statement, okay, about the decision made by the board. This one is a statement about the sample. Are we trying to make a statement about the sample? No, we know what the sample says. The objective of a confidence interval is to make a broad statement about the population. So which one should we pick? This one. Okay, so they try to throw you by putting in the word sample there. You have to have good eyes. Okay. So now we have 585 samples of seafood from various stores in different regions of the country, genetically compared. Some of them were mislabeled. In that sample, 38% were mislabeled. Construct a 90% confidence interval that were mislabeled. This time you're going to use StatCrunch, but I can tell you ahead of the time, There's nowhere in the stat crunch you can put the number 38%. What they're going to ask you in stat crunch in that dialog box is the number of successes and the number in the sample. How do we convert the 38%? Get some scrap paper for them out. How do we convert 38% mislabeled to a number that are mislabeled? I'm going to tell you, okay? 38% is 0.38. If you multiply the total number in the sample, 585 by 0.38, percentage of 585. But of course, you've got to change this to a decimal. So I asked you to bring your calculator. If you care to check me, that would be cool. 0.38 times 585. I am getting 222.3. Okay, a number of successes has to be a whole number. So I have to make a decision here. I'm going to call it 222.3. I'm going to call it 222. It shouldn't make that big a difference because the sample size is large. So get more help. Stat crunch. And I know I need a new share here. Okay, so here we are in stat crunch. We're going to go under stat, proportion stats. Whoops. One sample with the summary. So see how the only input it's going to accept is not percents, but number. So 222 were mislabeled out of a total of 585 sampled. And of course, I've already forgotten, was it a 90% confidence interval? Yeah. Yep, it was. Okay, back to forget about this. We're going to go back here. So it was a 90% confidence interval. Change this to 90% and compute. Here's our boundary values. Again, I don't remember what degree of accuracy they wanted, so let's just jot down 4 decimal places. 0.33466, and that would make this a 5, and 0.412, and that would make that a 5. Okay, so I'm going to move this over. I can't move it over. Okay, so what I'm going to do is I'm going to go back to your problem. That's not your problem. What was it? Was problem 4, I believe. I think we were working on problem 6. Oh shit, it's a different problem 6. Well, they changed it to 0.65. You know what? I don't want to waste your time. I'm going to change it to 0.65, and I'm just going to quickly redo it. Okay, clear. 0.65 times. Oh, no. $530. Okay. So we're gonna go back to StatCrunch. Sorry about this, guys. Okay, StatCrunch. So the number of successes, there's a new number of successes, it's 345. And the number of observations, 530. And they still want a 90% confidence interval. Okay. So the lower limit is a 0.6169, and it's a 0.6850. I know you can't see that. You're just going to have to trust me on it, okay? So we're going to go close that, go back to the thing here. And so what do they want? They only want one decimal place, and they wanted a decimal. So it's going to be 0.62 to, what is it? Oh, it's, they have percent. Have to pay attention to that. So this would be 61.7. And this would be 68.5. Well done. Okay. Moral of the story, what? If you're handed a percent, what are you going to do? Change that percent to a number of mislabeled, not a percent mislabeled. What does this mean? We are 90% confident that the interval captures the true proportion. We are 90, the word chance is a bad word. Samples is a bad word. This is what it is. Good job. All right, let's move on. Okay. Oh, 530 samples. Oh, we already did that one. Move on. Question 8. Oh, shoot. Question 8. Yes, I want to leave it. I want question 8. Okay.
We're still viewing the StatCrunch page.
Gotcha. Better?
Yes, thank you.
No problem. Thank you for telling me. Consumer advocacy group labeling seafood. Now they tell us 11 out of 25 were tested a different kind of fish. Are the conditions met? Again, yes, because the random sample those were the conditions I had in my PowerPoint. Construct a 95% confidence interval. We got lucky this time. They handed us the number of successes, 11, and the number sampled were 25. So we got lucky. We're going to do get more help, pick StatCrunch, and yes, I will share it with you. And this is it. So once again, we're going to do stat, proportion stats, one sample with the summary. We were handed the number of successes, 11, out of total of 25. And what was the confidence interval I wanted? Anybody remember?
I think it's 95.
Okay, we'll make it 95. Okay, compute. Okay, so the lower limit is 0.2454. Upper limit 0.634. 634 rounded up to a 6. Can you see that? If not, shh, my dog is whining. There it is.
We're still seeing the StatCrunch example from last time.
All right, gotcha. All right. Now you can see it, right? So I put in 11 successes, 25 observations, set it at 95%, and then I'm going to do compute. You can see this. So I've jotted down the 0.24 with a couple of decimal places, the 0.63 with a couple of decimal places, and we're going to go back. We're going to click out of this, and I'm going to have to do, oh my God, screen share. Okay, 95%. Here we are under new share. So now notice it doesn't say the little percent sign. Okay. The other problem had a little percent sign. So now they want a decimal. That can be very frustrating when you're doing a problem. And they want 3 decimal places. So 0.245 and 0.63 rounded up to 5. Cool. What does this mean? 95% of the time, I don't like that. One is 95% confident, I like the word confident, that between blah, 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 sold in for. What's the next one? This is very general, which makes me like that. That between all purchased for the study. Not 3 states. So assume that, okay. It says in 3, it says 3 United States. It says 3 United States. Okay. We'll put that in. Going to change this to a percent and make it 24.5. And we're going to make this 63.5.
Wouldn't it be one of the confidence, like the 95% confident, B or C? Because that one says there's a 95% chance.
Oh, bless your heart. Chance is a bad word. You're right. We're supposed to use confidence. Just a bad word. One of them is incorrect. What's the difference between these two? 95 sold in stores and restaurants.
I think it's because in C, it's saying that it's like the ones purchased in the study, but in B, it
In
says
the
whole
study,
thing.
it's more general. Yes. We want to be general. Okay. So when you hit this problem, remember, generality is important. Check your answer. Okay. So once again, take a look. Okay. This one doesn't mention any confidence or anything. This one says chance, which is a bad word. So we narrowed it down to these two. And the difference between these two are what's the subtle difference here?
Like Greg was saying, it says in the study. So you said not to like use it if it says in the study. The other one just says sold in food stores.
Purchase for the study. Perfect. Perfect. It is a subtle difference, but it is wicked important. Okay. Philanthropic institution sent mailings out to 100,000, and that generated 4,623 donations. Give a 95% confidence interval. That is actually a piece of cake because we know both the number of successes, 4623, and we know the size of the sample, which is 100,000. So this might be the last one we do of this type. We're going to do Stat Crunch, and we're going to do a new share. And here's good old Stat Crunch. Okay. So once again, we're under Stat, and we are going to do proportions. one sample with the summary. They handed us the number of successes for 6, 2, 3, and the number in the sample, 100,000. And they wanted 95%. Is that correct?
Mm.
Yep. Okay. So 95%, and we're going to compute. Can you, it seems like it's still in your window. So,
Yes, we can see it.
okay, so we're looking at 0.0449, 3.04753. Okay, close out of this. See if I can move this. Yep, I'm going to close out of this. And we're going to do a new screen share, which is the problem itself. Oh my God, a new share. Here's the problem. You can see it. So notice it says percent. Okay, so I'm going to have to change this to a percent, and it wants 2 decimal places. So it's going to be 4.4. Oh my God, all of this gets rounded up. 4.045. And then all of this gets rounded up. It's going to be a 4.8, 4.78. Hope I did my rounding correct. Okay, what did I do? So that gets rounded up to a 5.
I don't know if I'm right, but it might be 4.49 for the first percentage. That's what I wrote down.
Okay.
Instead of 5.
Okay, thank you, dear.
Yes, I got the same thing.
Perfect. Check answer. Try again. What about the upper bound? 3 decimal places. You've got to be out of your mind. So after that 9, it won't let me change that. Okay. So the problem is, I don't know what the problem is. I put that in there. They didn't like the first one. Okay, my apologies. Given the confidence interval you found is 4.9% plausible. Is 4.9% possible? Is 4.9% in this confidence interval? I don't think so. Upper bound is 4.75. 4.9 is where? Outside, it's bigger than the upper bound. So is it plausible? No, because it's not in the confidence interval. Okay. Let's see what we got here. And we'll move this up. This is exactly like the previous problem. They are handing you the number of successes and the number of of the sample size. And they want a 95% confidence interval. It's the same deal. Okay, so let's move on and see if there's something more exciting coming. Vitamin D, okay. So a recent study of 3,000 children found 22% of them were deficient. And we want a 98% interval. What do we have to do? The 22% is not something you can put as input. You need a number of kids that are deficient. So we have to change what? We have to change the what? The percent. So 22%, 0.22 of the sample, which is 3,000. We've got that extra little thing to do. 0.22 times 3,000 is a 660. So input is going to be 660 for the number that are deficient, 3,000 for the number in the sample. Okay. So to get more help, the stat crunch with the new share. Stat, proportion stats, one sample with the summary. And it was 660 kids are vitamin D deficient out of 3,000. I believe it was 95%. Is that correct? Let's just scoot it over. Oh, it was 98%. So I'm going to write down the decimals. And if they ask for the percents, we'll change it. 0.2024. And then a 1 following that. And a 0.23759. Here we go. What do they want? No mention of a percent sign, and they want 3 decimal places. So 0.202 and 0.23, and the 7 gets rounded up to an 8. Cool. What does it mean? 98% confident. This is bad, that a randomly sampled child. We're not making a statement about an individual child. We're making a statement about the general population. That's definitely wrong. I'm looking to see what's the difference between A and C. This says people This says children. I believe the study was done on children. Cool. All right. Now, again, I'm looking for something different. Yeah, we're leaving the question. All right. If the level of confidence increases, what happens to the confidence interval? So the Z values are getting bigger and bigger and bigger. Okay. So the confidence interval, if you put in a big Z value, the margin of error gets what? Margin of error gets larger. So the confidence interval gets wider. Shh. The margin of error decreases and the sample size remains the same, so that the margin of error decreases. And the sample size remains the same. That means the Z value must have gotten smaller. And when the Z value gets smaller, the margin of error gets smaller. Margin of error decreases, sample size remains. So that if the margin of error gets smaller, what's going to happen? The level of confidence is going to go down. Cool. And we're getting towards the end because there's 16 questions. To decrease the margin of error without decreasing the confidence level, obviously the sample size needs to get bigger. Is that the only is that? I thought there were 16.
Yeah, I think that's it. There's only 14.
There's only 14. Okay. I need to take a quick break. I am going to put you back to question number 1. Make sure it's still in your viewing window. Oh my God.
Yes, it is.
It is?
Mhm.
Okay. Give me a minute to take a quick break.
Did anybody else finish the assignment too?
No, not yet.
Yeah, it wasn't too bad. She kind of like shows you exactly how to do it in the videos and on that like example one that she put up there.
That's good. Good to know.
Greg, about how long did it take you?
Only like 2 days. Like I worked on it like one night and then most of it was just like watching the videos. And then when I went to do it, it wasn't like too long. How about you?
That's perfect. I was just wondering because I have to work on it tonight.
Oh yeah.
I just
Yeah,
finished like, a
I
research
thought it was
paper.
easier than the first one. It didn't seem like there was as much like to do.
Oh, that's good.
Yeah.
Thank you.
Yeah, it's only like when I look at it, it's only like one page of like work. The other one I felt like was like 2 or 3 pages when I submitted it.
Oh, it's not too bad.
So I am looking at the clock. We only have 10 minutes left to discuss.
Can I ask you a quick question about the assignment?
Sure, I'm
There was
going to
just one,
abort this, okay? I'm going to abort this. I'm going to leave this.
just
And
the
Yeah.
part where it was talking about the teen birth rate, and then it said like the units of measurement. I didn't know what it meant because it says like
can you tell me exactly what part that is? Assignment?
it's in a couple of parts, but I didn't know like what is the
Wait. Do me a favor.
yeah.
Let me do a new share, okay? I want people to see this.
Yeah, like what is the teen birth rate measured in? Is that like a percent? Like it says like if it says 13, like is that just like number of teens or is it because the other one, it's
Can
a
you,
percent.
you have the Excel file open? Because I don't think I have it opened.
Um,
Let me see.
I'm looking at one. I can just like give you an example. It
Wait
says
a
like
second.
Arkansas says 13. Like is that 13 like 13
Um,
teens or like
Give me
13%?
a second here. Oh my God. I'm not pulling up the rights. Okay, teen birth rate. Okay, so I'm looking at a number 49.7. That has got to be a percent, doesn't it?
Yeah, I wasn't sure because the other one like says percent. The other one says percent of teens not in school or working, and then the other one just says teen birth rate. So I didn't know if that one was like
Yeah,
a percent too.
as I'm looking at the data, it's got to be a percent.
That's what I thought
Yeah, it's got to
because
be a
one of the
percent.
things was saying like what the unit was, and I wanted to clear that up. I was like, I didn't know if it
I
was
can
percent or
imagine
like a
that.
number.
Yeah, yep.
That makes sense.
All the other columns do say percent and this says rate. And it has to be percent. We'll assume it's percent, okay?
Okay, that works for me.
Okay. All right. So,
Thank you.
no problem. So I'm gonna
I
close
also
up.
have a question.
All right, give me a minute there. I'm just trying to get everything else out of here. So where is? Okay, here is the assignment. What part of the assignment would you like to look at?
I had a question about the exam one review, because on my
Oh.
Canvas it shows as an assignment, but I remember you said that you're not gonna grade it,
Right,
so I could just ignore that, right?
right. I mean, it might show up on Canvas, but I have set Canvas so, you can assign percents to each column, and that has a 0% assigned to it. So don't worry if it shows up in Canvas.
Okay, thank you.
It is set to have a 0%. Don't worry about it. You okay, dear? All right. Let's get back to assignment 2 because it is due tomorrow. Have you started it and run into any questions? Basically, the deal is to what have we got here? I think we've got StatCrunch open somewhere. yeah, basically the deal is to, and let me see if I can get it up. Okay, here it is. And you can see this. This is the data set as it is opened in StatCrunch. Okay, so I think the first question asks you what? Juggling papers here. It says first, you're going to be doing stat and regression, and you're going to be doing simple linear. And you're supposed to pick for X the percent of teens not working. And you're supposed to pick the birth rate in the same year.
Oh, one thing I noticed I wanted to mention was on the assignment page, the link for the video isn't there, but like if you click on it, it doesn't do anything, but it's on your
think I
YouTube
changed it.
channel. So like if other people can't find it, if they just
I thought I changed that last night. How recently? did you
Oh,
check
I
that?
did it like last week, so maybe you did change it.
Oh, check it. It's there.
Oh, okay. I was just gonna say if other people couldn't find it, then if you
I
go to the
know, I
YouTube channel,
know.
it's up there.
It's there now. No, it really is there. Okay. So we're gonna do no, where, none of this stuff. But we are going to plot the line. And we want the residuals and the students standardized. And you're going to compute. And there's a whole bunch of stuff that comes up. And I think I mentioned this before. I want the equation highlighted, copy and paste it into your document. Okay. Then you don't have to do, any typing of the words teen birth rate and percent of kids not working. You don't have to type that, copy, paste it. It will have too many decimal places. So when you do your copy paste, delete the trailing decimals that you don't need. Then they want R squared. There it is. Copy, paste it. This is what you're supposed to interpret. This is the slope. The slope measures what? The change in Y, the change in the birth rate, the percent of teens that gave birth in 2019. And this is the percent of teens that are not in school in 2019. You always start from the bottom up, change in Y over change in X, as the percent of teens not working in 2009 goes up by 1. How much is the percent, is the teen birth rate going to go up by? Okay. And I think that's explained in the video, and I think it's explained in the notes. You start by talking about the kids not working going up by 1. And then you don't say it causes, you say it's associated with an increase of so much in the birth rate. Okay. So that's that particular piece of it. And then the other piece is, of course, the scatter diagram. You look at it visually and you make an assessment. Is it positive? Is it negative? If things goes up, if the line goes up, it's positive, the line goes down, it's negative. And you make an assessment.
I have the hat because I didn't do my roots. Look in the back.
Come again? Is there a question? Okay. I would encourage you when you're making your decision about whether it's weak, moderate, or strong, to maybe look at the correlation coefficient. You know, it's mid-range. It's not up there at 0.8, which would be strong. I don't know. It's a nice correlation coefficient, but it's not a powerful correlation coefficient. So you have to choose between weak, moderate, or strong. And I'll leave that up to you. Okay. Then you're going to have to deal with the residuals. Okay, see if I can move this over a little bit. The residuals. There's a little arrow here where you can sort them. Sort your standard, not the residuals. Sort the standard residuals. Look at them. If it's below -2, that's unusual. So this column is unusual. What other column is unusual? This one, I should say row. So there is an outlier in terms of this, which if I could ever move this over somehow. Let's just get over there. Find out. Really, let's move you guys over. Okay, it seems like it's Alaska. Okay, now, can you see this? Okay, I hope.
Yes.
Okay, so if we go back to, oh, I want to go back to the graph. It's Alaska. Okay, and I don't know where that graph went. Shoot. No, that's not it. Let's just bring the stuff up. Okay, let's look at the picture. Okay, now I've highlighted this. Look what happened. Look what happened when that row got highlighted. It all makes sense. This is a low, extremely low value. There it is. There's a picture of it. Can you see there's Alaska down there? And this was the high one. Look at that guy. That's Arkansas. It's way up there. Okay? So it's your job to look at these. I'm going to have to get over here again. It's your job to look at the residuals. This is what I want you to interpret. What does that 12.8 mean? Okay, what does it say about the teen birth rate in that state? I gave you lots of food for thought on the demo printout. Okay, so you've got to explain the residual. You've got to explain the residual. Not the student standardize. You've got to explain the residual. And I can't hand it to you. I'm going to encourage you to look at the printout that says, you know, assignment 2, video, the Word document. And the words are there. You just have to apply them to this particular data set. Are we cool?
Yes, thank you.
Okay, dear. Anybody that wants to stick around, you're welcome to do that.
Thank you, Professor.
Okay, no problem.
Have a great day.
You too.
Thank you.